Welcome to Leetcode. In this video, we will solve a Leetcode problem in under 3 minutes. The problem is as follows. We have a list of number pairs representing balloons, with each pair representing the range on the x-axis where the balloon is located. Specifically, for each balloon, we are given two numbers, x start and x end, which define the range where the balloon lies. Our goal is to burst all the balloons using the minimum number of arrows. Here, an arrow can burst a balloon if the range of the balloon's location includes the arrow. To solve this problem, it's important to remember that every balloon must be burst eventually at some point, and that the x-end value of each balloon can be thought of as the last opportunity to burst it with an arrow. Using this information, if it's possible to burst a group of balloons together, the last opportunity to burst them all is simply the minimum of their x-end values, which is equal to 3 in this example. Therefore, if the balloons are sorted by ascending order of their last opportunity coordinate, x-end, it's optimal to iterate through them and greedily burst each balloon at the x-end point if it hasn't been burst yet. Consider the following simple example. Here, we start bursting the first balloon at its x-end coordinate. For the second balloon, we can see that it has already been burst and don't have to do anything. Moving on to the third balloon, it is not burst yet, so we burst it again at its x-end point, which is 6. We can skip the fourth balloon because it has already been burst. Finally, the fifth balloon has not been burst yet and requires another arrow. Overall, the minimum number of arrows required to burst all the balloons in this example is 3. Let's take a look at a C++ implementation. If there is no balloon, we can simply return 0. Otherwise, we sort the balloons array by the ascending order of their x-end value. We start by bursting the first balloon at its x-end point, since it has the minimum last opportunity point and we want to burst as many other balloons as possible. Therefore, we initialize the number of arrows as 1 and the last arrow point as the first balloon's x-end value. We then iterate through the array. For each balloon, we check if it has already been burst by comparing the last arrow point with the current balloon's starting point. If it has already been burst, we do nothing and skip. Otherwise, we reset the last arrow point to the current balloon's x-end value and increment the number of arrows. I hope you found the solution we presented helpful and easy to understand. If you had any questions, don't hesitate to leave a comment below.